So I'm very pleased now to introduce Sophia. She is our policy officer at COGEN Europe, and she'll be presenting a paper focusing specifically on waste heat. We believe it's probably the first of its kind, looking at waste heat and looking at it in a more holistic way, looking at different pieces of legislation and how waste heat is treated. So I'm going to give you the floor, Sophia.
Thank you, Hans. Thank you very much. Hello, everyone. I'm Sophia Milusheva. I am Junior Policy Officer at COGEN Europe. And like Hans just introduced, I'm going to present to you the paper we have produced on waste heat, and especially its potentials, applications, and recommendations for better policies. So what we have heard so far from the Commission and also about the project, we're going to put in a bigger picture. So first, we have already been very kindly introduced as COGEN Europe, but maybe briefly to touch upon this, we are the European Association for the Promotion of Cogeneration. We are basically the cross-sectoral voice of the cogeneration industry. We have over 60 members, and our mission is to work with EU institutions and stakeholders to shape better policies, to eliminate administrative, regulatory, and market barriers to the wider use of cogeneration in Europe. And in this case, with the HEATLEAP project, COGEN Europe coordinates all communication and dissemination activities. So, like I said, let's have a look at the bigger picture of waste heat and use significant excess waste heat potential. So, despite efforts to prioritize energy efficiency, significant potential remains unexplored when it comes to reducing energy waste across the entire energy value chain and making the best use out of the energy that we have available. So waste heat recovery and utilization is a largely untapped energy efficiency resource, which represents important opportunities across many sectors and applications. Most energy losses in energy conversion, industrial processes, and energy consumption take the form of heat waste. And there is a range of waste heat recovery methods and application based on technical, commercial, and local circumstances. And waste heat may be used on-site or in district heating in the form of heat and or power. So in Europe, there is a significant potential for excess heat recovery from power production, industry, and commercial premises. And the Heat Roadmap Europe project has estimated that excess heat in the EU amounts to 245 megaton of oil equivalent per year, which corresponds almost to EU's total energy demand for heat and hot water and residential and service sector buildings. At EU level, waste heat due to energy conversion losses from power-only plants is nearly 200 megaton of oil equivalent per year, and that exceeds the total heating and cooling demand of European buildings. So when we look at the industrial excess heat across Europe, we see that industrial plants of energy-intensive industries dissipate between 30 to 60% of the overall energy consumed as heat dissipated into the atmosphere. Recovering this heat for either on-site use or for district heating supply could help improve energy efficiency on the site, reduce the carbon intensity per unit produced, reduce energy costs, and or also generate new revenue streams. Studies have assessed the technical potential for waste heat recovery from Europe's key industries by temperature level, estimated at around 25 megaton of oil equivalent per year. And in this figure, we can see the waste heat potential in each EU country by temperature level and country. We see that Germany is sticking out. We already touched upon the gas distribution systems, and essentially, Europe has an extensive gas distribution system contributing to EU's energy mix by more than 25%. And the theoretical potential for gas expanders in the EU can be as high as nearly 4,000 gigawatt hour of electricity production per year. And more than 50% of the fuel used in power-only plants is wasted in conversion, transmission, and distribution, mainly as heat discharged into the atmosphere. By comparison, high-efficiency cogeneration reaches total efficiencies between 75% and 95%, with losses being reduced to 5 to 25% of the energy input used. However, this potential remains largely untapped. And in this figure, you can see the aggregated heat losses from power-only plants in the EU. So next, let's touch upon the multiple waste heat recovery applications. As part of the HEATLEAP, our focus is waste heat. So we're going to overview the different applications for this, and you will hear about case studies later on. So depending on a range of factors, waste heat recovery can be implemented in different sectors and across a diverse array of applications and technologies. The first case you can see here is the direct use of heat in district heating. So district heating represents over 10,000 heat networks in Europe, covering 13% of heat markets and supplying more than 60 million citizens. And from 13% today, district heating could supply up to 30 to 50% of EU heat demand by 2050. However, there are also other applications. For example, the waste heat recovery for electricity and heat generation. So in addition to direct use of waste heat in district heating, there are cases when heat waste recovery is better suited for power and or heat production. And waste heat valorization in industrial processes can be achieved through the organic Rankine cycle in two different configurations. So the first one is the waste heat recovery by organic Rankine cycle in a power-only configuration that leads to electricity, or also the waste heat recovery by organic Rankine cycle and CHP. So this is the cogeneration configuration. Sorry. And in this case, there are outputs of this configuration that are electricity and heat, which can be used either on-site or delivered to nearby consumers via district heating. Then there is also the third case of combined heat and power configurations, so CHP. And CHP avoids waste heat in thermal power production and can use waste heat as a source. In this case, cogeneration can produce both electricity and capture the remaining heat whenever there is heat demand supply nearby. And this further improves the efficiency benefits of implementing organic Rankine cycle solutions to recover waste heat. But also, in addition, CHP can be a source of waste heat. So in some cases, a CHP system will generate power and process heat for an industrial site. And adding an ORC solution or simply capturing the waste heat for direct use in district heating could bring further efficiency benefits. Waste heat recovery is recognized in high-level use strategies and policies as an energy efficiency measure, a source of clean heat, and a more circular energy system with energy efficiency at its core. And an EU-wide definition of waste heat has been introduced in the Renewable Energy Directive, as you can see on the screen. And it covers the direct use of waste heat in district heating applications, as you can see also on the figure. So other EU legislation and provisions appear to prioritize the direct use of waste heat from industrial and commercial applications in district heating. This definition is set in the Renewable Energy Directive and used as a reference in other legislations such as the Taxonomy or the Energy Efficiency Directive. However, while EU policy centers across the direct use of waste heat in district heating, there are more opportunities to be unlocked for the potential for other feasible applications. So it would be good if all other applications that we just heard are captured across relevant EU legislation. And this is not to undermine the importance of waste heat in district heating. But despite the high-level recognition of waste heat across the EU legislation, the definitions and provisions permeating the waste heat are not sufficient to capture the full potential of waste heat recovery and do not cover the entire range of applications. So best practices implemented by industry today showcase a range of feasible applications for waste heat recovery, which deserve better policy recognition to be scaled up. And as demonstrated in this paper, waste heat can be used directly in district heating, but also for power production on-site and for grid fit-in. So this leads me to our recommendations we have. First of all, a recommendation would be to harmonize waste heat definitions to cover all relevant applications. So EU legislation provides a narrow definition limited to waste heat, which can only be used in district heating, like we saw. And this creates uncertainty among both industry and policymakers aiming to implement the legislation. Moreover, it risks excluding large volumes of untapped waste heat potential from energy and climate plans, and eventually Europe's energy mix as a whole. Secondly, we recommend to recognize all waste heat sources and applications in the energy and climate plans and assessments, which would mean to adopt policy measures giving visibility to the entire range of waste heat recovery solutions. There is a risk that other relevant uses and sources are overlooked in long-term energy and climate plans. And this will further limit the visibility of those potentials and contributions to overall energy and climate targets. Next, we do recommend to support and promote the waste heat as a clean energy source in new legislation. So due to the incomplete waste heat definition in the Renewable Energy Directive, references to it in other EU legislation result in the exclusion of important waste heat applications from different support schemes, funding, and also clean energy accounting. For example, in the EU taxonomy, it should be recognized that waste heat to power and or heat applications is and can be a clean energy source in green investment, or also in the EU emission trading system, it would be recognized that waste heat recovery from industrial processes for power generation is eligible for free allocation. Thank you very much for your attention, and the full paper is going to be very shortly on the HEATLEAP website. I give the floor back to you, Hans. Thank you.
Thank you, Sophia, and thank you for your comprehensive presentation. That presentation too will be also made available online on the HEATLEAP website. And the paper itself will be online this afternoon, available for everyone to review. Now we have time for some Q&As. I've noticed that people are starting to ask questions. But it seems that actually most of the questions have been answered already. There was a general question about what is MTOE, million tons of oil equivalent. That's yes. Quite straightforward now. Any other questions? We still have Claudia Canavari, the head of unit for energy efficiency from DG Energy. She's still with us, but she will have to leave shortly. So if there are any other questions, or maybe Claudia would like to react to what you've heard so far from Marco Baresi or from Sophia regarding the waste heat paper.
Thank you, Hans. No, not really. I think it's very interesting, and I'll be happy to read the paper, but no immediate reaction at the moment. Thank you.
Thank you, Claudia, and thank you again for agreeing to give the keynote speech. You're almost patronage of the HEATLEAP project, so we're very pleased for the support coming from the European Commission and your unit in particular. Maybe a question here for Marco in the Q&A function. Will some sort of heat storage integrated into a HEATLEAP project?
No, not specifically.
Okay. And there was another question regarding the PFD schematic was seeing that the water was leaving the heat pump by 95 degrees. I don't know if you saw that question.
But I suggest if there are some technical questions, we can address directly to my colleagues and give you directly reply. So
no, that's
in order to.
It's a fair point, Marco. Yeah.
Yes.
Most of these questions are quite technical, but
yes.
There was a good question here regarding the role of heat exchangers in large heat pumps, and what is the role of heat exchangers and large heat pumps and gas expanders? Is that something maybe more general that you can address, Marco?
Yes, large heat pump is quite similar to the ORC technology. So it means that there are evaporator and condensator, and so basically they are heat exchangers. So there are a lot of heat exchanger into the project. So I don't know the specific question, but of course is a key component, are the key components.
There's a very simple question. Is the heat pump linked to the HEATLEAP project, is it already in operation?
Yes, is in operation and is currently not in full commercial operation due to the fact mainly that the heat season is closed, and so we cannot deliver the heat to the district heating like, for example, the winter season. But we are doing a test and we are in operation. So it's a concrete project, real project. The restart for full commercial operation will be in October when we start the winter season.
Okay, thank you, Marco. I'm just going through the questions quickly here. Maybe a technical question, but maybe something you can answer as the last question, and then we can move on to the case studies themselves, where I'm sure we'll get more practical demonstration of waste heat recovery in different applications in different countries.
Sorry, Hans, if I interrupt you, related to the storage, most probably in the other section, when there is a specific description of the Ori-Martin plant, we can go deeper, because there is no storage system, but the system to generate the steam is a sort of storage system. So I give the possibility to reply to the colleague from Ori-Martin later. Thank you. Okay,
thank you. Fair point. All right, then. Well, let me thank our three speakers again. Thank you to Claudia Cannavare, Head of Unit for Energy Efficiency from the European Commission. Thank you for joining us. And thank you to Sophia to present the new HEATLEAP waste energy paper, which will be made available this afternoon. And also thank you to Marco for giving a good overview of the HEATLEAP project. And just as a reminder again that the HEATLEAP project will be coming to an end, and we'll have a final dissemination event on the 6th of July in Brussels. It will be a hybrid event, so if you cannot come physically, you still have the opportunity to follow and learn the final results of the project.